Alright, so in this video, now we're going to take a look at covalent compounds. So with ionic compounds, we were looking at cations and anions canceling each other out to be zero. So recall that when we wrote an ionic compound, or particularly when we named an ionic compound, we never actually had to indicate how many of the cation and the anion there were, because intuitively, if we knew what the charges of them were, and we knew that we had to cancel it out to be zero, you could deduce how many of each cation and anion there were. So there was no need to actually indicate the quantity because our overall focus was the charge. In a covalent compound, since we're not dealing with ions because electrons are shared, there's no way for us to know how many of each element there are unless it's actually specified in the name. So for covalent compounds, and particularly we're going to be first looking at binary covalent compounds, which means that there is only two elements in the compound. We need to actually show the quantity using Greek prefixes. So real quickly, I want you to take a look at this list. Obviously, you can have more than 10 atoms in a particular molecule, but for this level of chemistry, you usually won't see more than 10. And so take a look at the Greek prefix that goes along with each number. A lot of them are kind of obvious because we've seen them in a lot of ways. Like for example, 2 is di, 3 is tri, 6 is hexa, like hexagon, 8 is octa, like octagon. So those are common ones, but there are some ones that might be new to you. For example, 1 is mono, which you may have known that, but maybe not. 4 is tetra, 5 is penta, 7 is hepta, 9 is nona, and then 10 is deca. So those are some maybe ones that you aren't so familiar with. So it's really important that you commit to memory these 10 prefixes because you won't have them on a cheat sheet for an exam. You'll need to know those. Alright, but as far as the naming goes and the writing of the formula, it's actually pretty easy. It's very straightforward because the name of the compound is actually indicating how many of each element there are. So here's what you do. The first thing you want to do when you're given a formula and you're asked to write the name is name the first element as is. It's very similar to ionic. You know, the first element was the cation. You never changed the ending or anything like that. You always just wrote it. In the same way, you're going to name the first element just as it is on the periodic table. But you need to add the appropriate prefix to the beginning of that name in order to signify the number of atoms for that first element. The only prefix you will not use for the first element is mono. So you'll exclude mono for the first element even if there's only one. So if you look at the first element in a covalent compound and it doesn't have a prefix, it's assumed to be 1. Now the second element, you are going to change the ending to IDE just like we did with ionic. However, we need to add a prefix just like we did before, and this time you will add a prefix indicating no matter what number it is, even if it's only 1, you do need to include mono. So the only time you do not include a prefix is if you only have one of the first element. Alright, so let's do some practice so you can see how easy or straightforward this is. Okay, let's look at the first one. So the first element is nitrogen, so you're going to write it just as is. Alright, so nitrogen, but you need to add a prefix to indicate how many you have. There are 2 nitrogens, and so the prefix for 2 is di, and so I'm going to add di right on there, and it all becomes one word, so dinitrogen is one word. For the second element, you need to change that element to the IDE ending. So phosphorus becomes phosphide. You don't really see phosphoride, so we're going to write phosphide. Okay, but we need to add to the beginning of that how many phosphorus we have, and it's 5, so that's penta. And so we're going to add penta to the front of that, and I didn't leave myself a lot of space here. There we go. But it all becomes one word, so it would be dinitrogen pentaphosphide. Okay, let's take a look at the second one. So CS. So the first element is carbon, and we're going to write carbon just as is. So we don't have to change the ending. Now we need to add a prefix, but notice that there's only one carbon. For the first element, if there's only one, you do not include mono, and so we're just going to leave it as carbon. For the second element, sulfur needs to get changed to sulfide. And then we need to add a prefix to sulfide. There's only one sulfur as well, but because it's the second element, we do need to add the mono prefix. Alright, and so that name would be carbon monosulfide. Now the third one, I like to put this one because a lot of times students look at that and they say, wait, isn't SO3 sulfite? And it's not. If it was sulfite, it would be SO3 and it would show the charge, and sulfide has a -2 charge. So if I asked you to name SO3 with a -2, the answer would be the sulfite ion. But that's not what I'm saying. I'm saying write the neutral compound SO3. And so that is going to be our our covalent naming rules that we just learned. So the first element is sulfur. We're going to write it just as is. There's only one of them, so no prefix. The second element is oxygen. That gets changed to oxide. There are oh, that looks weird. All right, let me write that. The second element, there are 3, so we need to add the prefix tri. So sulfur trioxide is going to be the name of that compound. All right, so now that you know how to write the names, going the opposite direction and writing the formulas should be very simple. So let's take a look at these. So sulfur tetrafluoride. So sulfur is S. Notice there's no prefix, so it's assumed to be 1. Tetrafluoride, well, fluoride is the element fluorine, and the prefix tetra tells us that there are 4. Second problem there, tetraphosphorus. So phosphorus is the letter P. Tetra means we have 4 of them. Decasulfide. Sulfide comes from the element sulfur. And deca means 10, kind of like decade. And then finally, we have tribromine. Bromine is Br. Tri means that there are 3 of them. And then heptoxide. Oxide is oxygen. And then, now notice hept. We remove the A from hepta because it would sound really weird if we said heptaoxide. Kind of sounds like there's like a pause in the middle. So usually if there's 2 vowels together, like heptaoxide, we'll remove the last vowel on the prefix, just making it heptoxide. It makes it flow better. But nevertheless, hepta means 7. All right, so very simple, a lot easier, a lot more straightforward than ionic. The only difficult part of covalent compounds, however, is there's a lot more exceptions than there were ionic. And so simple naming rules, however, there are a few exceptions we need to cover. Okay, first of all, these 2 compounds right here. When you have compounds that contain tin or lead, tin is Sn and lead is Pb. These compounds, because tin and lead have slightly higher electronegativities than most metals do, they actually border right along the ionic covalent classification. And so we haven't gotten to this yet. We'll get to it in topic 6, but that electronegativity difference is very indistinguishable sometimes between ionic and covalent. And so all that to say, when you see these compounds with tin and lead, a lot of times you will see them using both naming conventions. Some people will name them according to the ionic naming conventions that we learned in the last video, and some people will name them based on the covalent naming that we just learned. And so you'll notice that the SnCl4, so this first one right up here, can be actually named 2 different ways. If it's named ionically, it'll be named tin 4 chloride, but if it's named covalently, it'll be tin tetrachloride. The same thing with the PbCl4 compound here. The ionic way of naming it is lead 4 chloride, and the covalent way is lead tetrachloride. To make things easier for us, because tin and lead are metals, I will always name these compounds using ionic naming rules. And most of the time, that's actually how they're named. But just be aware that if you're ever out there looking at chemistry literature somewhere, you may actually see these compounds named covalently, like tin tetrachloride or lead tetrachloride, something along those lines. And I don't want you to be freaked out by that. So just be aware of it. But like I said, because they're metals, we'll name them based on ionic rules. Okay, there's 2 more exceptions this video will cover: carbon-based compounds and then hydrogen-based compounds. So you may be familiar with the idea of organic chemistry. And organic chemistry is simply looking at organic compounds. It's the compounds that are carbon-based, or a lot of times people say it's the compounds containing to life. So compounds that contain carbon a lot of times have different naming conventions. For example, CH4, if you were to name CH4 based on what we just learned, you would name that carbon tetrahydride. However, CH4 is actually named methane, and you may have heard of methane before. You may have heard of these other compounds: ethane, propane, butane, pentane, and so on and so forth. So you notice there's some different naming conventions there. I don't need you to know all of the organic naming conventions because there's a whole class on that. all I need you to know is these 5 very common carbon-based compounds. I need you to know these names for these particular compounds. And more specifically, the one you're going to see the most is this first one. At our level anyway, the one you're going to see the most is methane. I'm going to move that asterisk so it's not covering the 4. There we go. You'll see that one the most. But I want you to see that there is a trend here. So obviously we're looking at a compound containing carbon and hydrogen, and these actually are called hydrocarbons. Any compound that contains just carbon and hydrogen, they're called a hydrocarbon. So I'll write that out to the side here so you know that. Hydrocarbon. And hydrocarbons have a general pattern. So you look here, and if you have a certain number of carbons, let's say N is your number of carbons, your number of hydrogens is always going to be 2N plus 2. And so, for example, let's just choose propane right here. Okay, notice that there are 3 carbons. Okay, and so the number of hydrogens, you could do 3 times 2 is 6, plus 2 is 8. So that's actually how you can figure out how many hydrogens would go with that. This is a little bit more than you need to know right now necessarily. Like I said, all you need to know is you are responsible for knowing these 5 compounds and that they are exceptions. So for example, on an exam, if I ask you to name CH4, the correct answer there is methane. Do not write carbon tetrahydride. You will get that incorrect. And then the other exception I want to cover in this video are the hydrogen compounds. Hydrogen compounds, just like it sounds, they are hydrogen-based compounds. And so you can just take a look at, this list here. You can see that, obviously there's some different naming conventions than we're used to. For example, B2H6, that would not be diboron hexahydride like we learned earlier. It would just be diborane. They have special namings. The only ones I need you to know are 2 of them, the ones in red. So NH3, don't name that nitrogen trihydride. Instead, we're going to name that ammonia. So once again, if you name that nitrogen trihydride, you're going to get it incorrect. You need to name it ammonia. I really hope you don't need help remembering this second one. If you see water, do not write dihydrogen monoxide. Sounds like a poison, but it's not. It's something you need to live, and so we are just going to name that water. Alright, so this concludes the video on covalent compounds. Next, we're going to take a look at specific hydrogen-containing compounds, which are going to be called acids.